The effects of kindness are not always seen immediately. Sometimes it takes years until your kindness will pay off and is returned to you. And sometimes you never see the fruits of your labors, but they are there, deep inside of the soul of the one you touched. A very warm good morning to all my dear students. Let us now begin with our 15th session. Today we will be starting with our new geography chapter, that is chapter 2, In Search of the Source of Wind. 8th July 1497. Vasco da Gama started his voyage in 4 ships from the port of Lisbon with a crew of 170. It was the longest voyage ever attempted in search of a country. They reached the coast of Brazil and from there they travelled to southeast. The winds identified by Bartholomew Dias aided Gama and took him to the southern coast of Africa. However, Gama left the place due to disputes with the local government. He sailed past Mombasa and reached Malindi. On sighting Indian merchants there, he sought the help of a local navigator and set sail on 24th of April 1498. With the help of the southwest monsoon winds, he reached Kapad near Kozhikode on 20th of May after a voyage of 23 days. But Gama struggled a lot when he tried to return during the southwest monsoon season itself, neglecting the advice of the experts. It took him 132 days to reach Malindi. So children, what do you understand from this context? It describes about how Vasco da Gama sailed thousands of kilometers from Lisbon to find a new sea route to India. It is very clear that the winds and an unyielding will helped Vasco da Gama to find a new sea route to India. Thus, the winds played an important role in his voyage, that is the journey, which changed the course of our land's history, is worthy of mention. Now, let us see what is wind or how do we define wind. The horizontal movement of the air from high pressure zone to the low pressure zone is defined as wind. So what is wind? The horizontal movement of the air from high pressure zone to the low pressure zone is defined as wind. Wind is the movement of air caused by the uneven heating of the earth by the sun and the earth's own rotation. Winds range from light breezes to natural hazards such as hurricanes and cyclones. So what is wind? The horizontal movement of the air from high pressure to low pressure zone is called wind. Children, you all have heard the term pressure, right? Then let me ask you, what is pressure? Pressure means the force you produce when you press something. Say for example, if you apply pressure with your fingers on a wound or an injury, it will stop bleeding. Yes? Now, what is atmospheric pressure? Atmospheric pressure is the weight of atmospheric air. Atmospheric pressure is caused by the gravitational attraction of the planet on the atmospheric gases above the surface and is a function of the mass of the planet, the radius of the surface and the amount and composition of the gases and their vertical distribution in the atmosphere. It is changed or modified by the planetary rotation and local effects such as wind velocity, density variations due to temperature and variations in composition. Now, what is the basic reason for wind? So, atmospheric pressure is the weight of atmospheric air and the variations in the atmospheric pressure are the basic reason for wind. So, what do you mean by atmospheric pressure? Atmospheric pressure is the weight of atmospheric air. What is the basic reason for wind? The variations in the atmospheric pressure are the basic reason for wind. What are the atmospheric variations and their effects? The average weight that air exerts on the Earth's surface is 1034 mg per centimeter square. The atmospheric pressure is measured using an instrument called mercury barometer. It is recorded in units like millibar, that is MB, and hectopascal, that is HPA. The level of mercury at normal atmospheric pressure will be 76 centimeter. The atmospheric pressure at that point will be 1013.2 MB or 1013.2 HPA. Children, look at the picture. You can see places A and B. Place A is located at a higher altitude and place B is located at a lower altitude. Now children, atmospheric pressure and altitude are inversely proportional to each other. So atmospheric pressure and altitude are inversely proportional to each other. That is, when altitude is high, atmospheric pressure will be low. Whereas when altitude is low, atmospheric pressure is high. So once again, when atmospheric pressure and altitude are inversely proportional to each other, as a result, when altitude is high, atmospheric pressure will be low. When altitude is low, atmospheric pressure will be high. So here in this picture, place A is located on a higher altitude, which means the atmospheric pressure on place A is lower, whereas place B is located on a lower altitude, and so the atmospheric pressure experienced on place B is high. As one goes up, the atmospheric pressure decreases, and as one goes down, the atmospheric pressure increases due to the rarefication or thinness of air in higher altitudes. Now let us see how atmospheric pressure and altitude are inversely proportional to each other. We already discussed that as we start moving to a higher altitude, atmospheric pressure decreases. The atmospheric pressure decreases at a rate of 1 millibar per an altitude of 10 meters. So the atmospheric pressure decreases at the rate of 1 millibar per an altitude of 10 meters. Here there is a decrease in atmospheric pressure due to rarefication or thinning of air in higher altitudes. As we move towards a lower altitude, atmospheric pressure also increases. The atmospheric pressure and the altitude are inversely proportional. Explain. The atmospheric pressure decreases with altitude. The pressure decreases at the rate of 1 millibar per an altitude of 10 meters. As one goes up, that is as one moves towards higher altitudes, there is a decrease in the atmospheric pressure due to the rarefication of air with altitude. The atmospheric pressure and the altitude are inversely proportional. Altitude is an important factor influencing the atmospheric pressure. Now, let us see why the mountaineers carry oxygen cylinders when they climb higher altitudes. So, the atmospheric pressure decreases at the rate of 1 millibar per an altitude of 10 meters. That is, as altitude increases, atmospheric pressure starts decreasing. And so, the oxygen cylinders help the mountaineers to breathe at higher altitudes, as there is a decrease in atmospheric pressure due to the rarefication of air with altitude. Now let us see how temperature and atmospheric pressure are inversely proportional to each other. Air gets expanded when it gets heated. As the expanded air is less dense, it starts moving up. Due to this process, the atmospheric pressure becomes low. The air that moves upwards starts spreading to the sides and then starts cooling. This cool air becomes dense or heavier and starts coming down, due to which the atmospheric pressure increases. The atmospheric pressure decreases as the temperature increases, and the atmospheric pressure increases as the temperature decreases. Thus, the temperature and the atmospheric pressure are inversely proportional. So, temperature and atmospheric pressure are inversely proportional to each other. Explain. Like any other object, air also expands when it gets heated. The expanded air is less dense and hence it ascends. This leads to the lowering of atmospheric pressure. The ascending air spreads to the sides and then starts cooling. On cooling, it becomes dense and starts descending. As a result, the atmospheric pressure increases. The atmospheric pressure decreases as the temperature increases and vice versa. Children, look at the picture. In the first picture, during daytime, the temperature increases. That is, the air gets heated up and starts expanding. This expanded air is less dense and it starts ascending. This leads to the lowering of atmospheric pressure. So once again, in the first picture, what happens? During the daytime, the temperature starts increasing. The air gets heated up and starts expanding. This expanded air is less dense and then starts ascending. This leads to lowering, or atmospheric pressure is less during the daytime. In the second picture, during night time, the temperature decreases. The ascending air spreads to the sides and finally starts cooling. As a result, this cool air becomes dense and starts descending. This leads to increase in atmospheric pressure. So once again, in picture B, or that is picture 2, during night time, the temperature starts decreasing. The ascending air spreads to the sides and finally starts cooling. As a result, this cool air becomes dense and starts descending. This leads to increase, or atmospheric pressure starts increasing. Compared to the colder regions, the tropical regions experience low atmospheric pressure. Why? So, in tropical regions, the temperature is high. As temperature increases, air starts expanding and starts rising up. So, the air here is less dense. Thus, atmospheric pressure decreases. Whereas in colder regions, the temperature is low and the air starts cooling as it moves to the sides. Air becomes more dense and the atmospheric pressure starts increasing. So, the atmospheric pressure and temperature are inversely proportional to each other. The temperature in tropical region is higher than that of the colder region. So, compared to the colder regions, the tropical regions experience low atmospheric pressure. Now, let us see what is humidity. Humidity means the quantity of water present in the atmosphere. That is, it is the concentration of water vapor present in the air. Water vapor, the gaseous state of water, is generally invisible to the human eye. Humidity indicates the likelihood for precipitation, dew or fog to be present. Thus, humidity plays an important role in our daily weather. So, what is humidity? Humidity refers to the quantity of water present in the atmosphere. What is humidity? Humidity is the quantity of water present in the atmosphere. Now, let us see how humidity and atmospheric pressure are inversely proportional to each other. We already studied that humidity means the quantity of water present in the atmosphere. As water vapor is lighter than air, it starts rising. As the quantity of water vapor increases in a unit volume of air, naturally the atmospheric pressure will be low. And if the quantity of water vapor decreases in a unit volume of air, naturally the atmospheric pressure will be more. Thus, humidity and atmospheric pressure are inversely proportional to each other. So, humidity refers to the quantity of water present in the atmosphere, Water vapor is lighter than air and hence it starts rising or starts ascending. If the quantity of water vapor is more in a unit volume of air, then naturally the atmospheric pressure will be less. Humidity and atmospheric pressure are thus inversely proportional to each other. Children, now look at the map of India. In the map, point A is located near the coastal area, wherein the water vapor is more. That is, humidity is more and so the atmospheric pressure is low. Now moving on to point B. Point B is very far away from the coastal area or the sea, and thus the water vapor is low. That is, humidity is low and so the atmospheric pressure is high. So once again, point A is located near the coastal area. As a result, humidity is more. So when humidity increases, atmospheric pressure decreases. Point B is located far away from the sea. Here, the humidity is low. When humidity is low, as a result, atmospheric pressure will be high. Now, let us go through the factors that influence atmospheric pressure. There are three main important factors that influence atmospheric pressure. They are altitude, temperature and humidity. So which are the three factors that influence atmospheric pressure? Altitude, temperature and humidity. Once again, altitude, temperature and humidity are the factors that influence atmospheric pressure. Now, let us study or learn the topic called isobars. Now before that, let me ask you, what do you mean by isotherms? Isotherm is a concept which you have already studied in your 9th standard. So what are isotherms? Isotherms are imaginary curves on a map connecting points having the same or equal temperature at a given period of time. Here, isobars are imaginary lines joining places having the same atmospheric pressure. In map A, the atmospheric pressure is increasing from south to north. That is, high pressure is experienced in map A. Whereas in map B, the atmospheric pressure is decreasing from south to north. That is, low pressure is experienced in map B. So once again, what are isobars? Isobars are imaginary lines joining places having the same atmospheric pressure. So what are isobars? Isobars are the imaginary lines joining places having the same atmospheric pressure. So in this picture, map A, what happens? Atmospheric pressure is increasing from south to north. As a result, high pressure is experienced in the first picture, that is the first map. Now moving on to the second map, that is map B. Here the atmospheric pressure is decreasing from south to north. So the low pressure is experienced in map B. Now let us study about global pressure belts. The distribution of atmospheric pressure across the latitudes is termed as global horizontal distribution of pressure. Its main feature is the zonal character known as the pressure belts. The atmospheric pressure is more or less the same between certain latitudes. Global pressure belts are permanent geoclimate features on Earth produced by the differential heating of its surface. Based on this, the Earth's surface is divided into different pressure belts. Thus, the horizontal distribution of air pressure across the latitudes is characterized by high or low pressure belts. So, what are global pressure belts? The atmospheric pressure is more or less the same between certain latitudes. The distribution of atmospheric pressure across the latitudes is termed as global pressure belts. So what are global pressure belts? The distribution of atmospheric pressure across the latitudes is termed as global pressure belts. Based on this, the Earth's surface is divided into different pressure belts. We already studied in our previous slide that the Earth's surface is divided into different pressure belts. They are, firstly, equatorial low pressure belt. Which is the first one? Equatorial low pressure belt. Second one, subtropical high pressure belt. Which is the second one? Subtropical high pressure belt. Thirdly, subpolar low pressure belt. Which is the third one? Subpolar low pressure belt. And finally, polar high pressure belt. Which is the fourth one? Polar high pressure belt. So which are the four different pressure belts? Equatorial low pressure belt, subtropical high pressure belt, subpolar low pressure belt, and finally polar high pressure belt. Now let us firstly study the first pressure belt, which is equatorial low pressure belt. Here the sun's rays fall vertically throughout the year in this zone. Thus the temperature will be high in this zone throughout the year. Due to high temperature, the air expands and rises up. Thus, a low pressure is experienced throughout the equatorial zone. This belt is situated between 5 degree north and 5 degrees south latitudes. As the air in the equatorial zone rises up on a large scale, the winds are very weak here, and thus this pressure belt is also known as doldrum, which means the zone with no wind. So, what is doldrum? Doldrum means the zone with no winds. This region was a nightmare for the ancient mariners. Equatorial low pressure belt. This is the zone where the sun's rays fall vertically throughout the year. Hence, the temperature will be high in this zone all throughout the year. The air expands due to the sun's heat and rises up on a massive scale. This is the reason for the low pressure experienced throughout the zone. The equatorial low pressure belt is situated between 5 degree north and south latitudes. As the air in this zone ascends on a large scale, winds are very feeble here. That is, winds are very weak here. This pressure belt is also known as doldrum, meaning the zone with no winds. The region was a nightmare for the ancient mariners. Now moving on to our second pressure belt, which is the subtropical high pressure belt. The hot air ascending from the equatorial low pressure belt starts cooling down gradually and becomes less intense or less dense at the subtropical zone due to the rotation of the earth. Thus, the temperature becomes low in the subtropical region, causing high atmospheric pressure all along this zone. The subtropical high pressure belt is situated between 30 degree north and south latitudes. So, subtropical high pressure belt, the hot air ascending from the equatorial low pressure belt cools gradually and subsides at the subtropical due to the rotation of the earth. The subtropical high pressure belt is situated between 30 degree north and south latitudes. Moving on to our third global pressure belt, which is the subpolar low pressure belt. The subpolar low pressure zone is located close to the polar regions. The air is colder here and the cold air remains close to the earth, and this air is thrown away due to the rotation of the earth. So once again, subpolar low pressure zone is located close to the polar regions. Here the air is colder and the cold air remains close to the earth, and this air is thrown away due to the rotation of the earth. Thus, a low pressure is experienced all along the subpolar region. The subpolar low pressure belt is situated between 60 degree north and south latitudes. So, subpolar low pressure belt, this zone is close to the pole. The air is colder here. Though the cold air remains close to the earth, the air is thrown away due to the rotation of the earth. As a result, low pressure is experienced all along the subpolar region. The subpolar low pressure belt is situated between 60° north and south latitudes. If the earth did not rotate, would there have been low pressure in the subpolar region? If the earth did not rotate, the cold air in the subpolar pressure belt will not be thrown away and the same air would circulate in the region. So answer is no. If the earth did not rotate, the direction of the winds would be another. Now moving on to our last global pressure belt, which is the polar high pressure belt. The polar high pressure zone experiences severe cold throughout the year and the air remains chilled due to the extreme cold that prevails over the poles, causing high atmospheric pressure in the zone. The polar high pressure belt is situated between 90° north and south latitudes. So what is polar high pressure belt? The polar high pressure zone experiences severe cold throughout the year and here the air remains chilled due to extreme cold that prevails over the poles, causing high atmospheric pressure in the zone. The polar high pressure belt is situated between 90° north and the south latitudes. So the zone experiences severe cold throughout the year. As a result, the air remains chilled under the extreme cold that prevails over the poles and this contributes to the steady high pressure experienced here. The polar high pressure belt is situated between 90° north and south latitudes. The rotation of the earth and the variations in the amount of sunlight contributes to the formation of different pressure belts. The pressure belts change according to the apparent movement of the sun. The pressure belts shift or move towards its northward during the period of the sun's northward movement and towards the south during the period of its southward movement. Moving on to our assessment area. Answer these questions in your notebook. Question 1. Which factors influence the atmospheric pressure? I repeat, which factors influence the atmospheric pressure? Second question. How does the atmospheric pressure increase? Second one. How does the atmospheric pressure increase? That's all for today. I hope I was clear to you in my session. Stay home, stay safe.